in Chong University, Seoul, South Korea. And in the architecture department, my subject is a little bit different than yours. It's about architecture and urban design. So me and my colleagues, we have developed a simple tree design tool using the visual algorithms. And this project is a collaboration between Hangrim Architecture Company and Chonggang University. So to start with, I will start with the background and the purpose of this research, and then some experimental technique and the results of the experiment, and the discussion at the conclusion. So the reason why I did this research is I found some challenges in the urban vegetation. Usually the cities, the metropolitan cities try to increase the greenery in their urban cities. However, the way they approach the greenery and especially the trees, lack a lot of problems, and we can see in the left side here, like for example, you can see like trees growing and stroking the electric poles, or you can see here like the tree planting pit is too small, so the tree is moving up and destroying the sidewalk here. Or we can see here the scale of the tree is much bigger than the building itself, so that it's covering all the light and the view of these buildings. Or we can see the trees affecting on the sidewalk here. So even though the trees have advantages in the urban environment, we should also consider how and how to approach them and how to place them in the urban fabric context in order for it to play as a vital urban element and be comparable with the other urban fixtures in the urban context. So we have some previously we have some design tools for the in the urban context. For example, we have a commercially developed software called ArcGIS. And we have iTree design platform where you can monitor and do some tree designing. The problem with these softwares is all of the softwares, first, they require previous knowledge in the urban design and in the city or the urban context that you are designing. Second of all, you need to import all of the existing data into the program for it to run. And the third important point is that it's a closed-ended program, which means that once you do the design and the result is on, you cannot change the result, and you cannot go back in the history of your design and change some parameters. And that's where the strength of the visual algorithm comes, where it's an open-ended design approach, where you can go back into your history for design and change the parameters, and your result will correspond with that, and it's going to change. So my goal was to build a very, very simple urban design tool that focused only on the vegetation, that people without prior knowledge can use to shape their own city. So in order for this tool to work, it has to be comparable with the city policies. So what we did is we targeted Seoul City, and we targeted some regulations from the forest management in Seoul. And we tried to convert some of the textual roles they have for vegetation into mathematical roles in order to integrate them into our approach. And some of these roles are, for example, the distance between the trees, the distance between the tree and the road. And we convert this into some kind of mathematical logics here. And also there have been another planting project in Australia called the Tree Impact Group. They have already developed some specifications and some simple design regulations for tree species. Like for the tree to grow up in an urban context, it needs some kind of specific regulations, and they have already developed these regulations for the tree species growth, and we adopted some of their rules and we integrate them with the city rules that we adopt from the soil forest management, as you can see here and here. And then what we did is to solve the problem of the proportion of the tree DH, depth to height, compared to the DH of the urban context, which is the depth to height of the street to the building. Like for the tree to work at least to be comparable and optimized with the urban street building height, we classified our trees into three classifications, into three classes. We have class A, which is these type of tree species, which are tall, like slender growing species, and we have the medium height trees, and then we have the small size scale trees. Basically, we targeted the architectural specifications of the trees, like the shape and the size and the scale of it in relation to the urban context. And then we translate everything into an architectural model where we made some configurations about how much should the tree be, like the distance between the tree and the building or the street, or like the tree when it's gonna grow, how much it's gonna grow, how much is gonna be the shape of the tree, and so on and so forth. So all of the previous regulations, we have translated all of them into some kind of architectural configurations and parameters. As you can see here, we solved the, we targeted also like how the tree should be placed in the planting pit and how much should be the planting pit here. So for our program to work, we the architecture, the methodology architecture is we have some inputs, and our inputs is for you as a user, you have to first import some information to the model to work, like which pathway or which sidewalk are you going to target to do the design, and then what are the specifications or parametric, the design parameters that you want to choose. And the program itself, like the hidden layers of the program, we have a design agent where it's going to take all of your parameters and convert them into the visual algorithm. And also it's going to take the geographic data automatically from the cloud and it's going to integrate them into our visual algorithm. And also we have an environmental agent when it's going to analyze the whatever design you choose, the parameter you choose is going to do some environmental analysis for it. And we have the construction agent where it's going to build the construction drawings for you and build up a QR code where you can like get all of the quantity takeoff of your design. And we have the coordinator agent where it coordinates all of the between all of these agents. And the output, you will have a 3D model of your vegetation with its environmental analysis and its quantity takeoff and all of the construction drawings needed to implement this design in reality. So the user interface is still under development. So simply the user can can choose from these drop-down menus and these sliders. He can simply choose the tree shape, and he can simply choose the like vegetation box size and height. He can simply move these sliders, and he can choose from the bench design. We have proposed 3 bench designs, and then he can the user can choose the size of the bench, and simply the program will start running and is gonna produce a QR code for the automatically is going to produce this QR code for the quantity takeoff of the building, and it's going to also give you some of the environmental analysis. For example, the radiation analysis, the visual analysis, the sunlight, how much the design you choose is the sunlight for is going to the gain of the regarding the vegetation in that building, depending on your parameters. And you will get also some construction drawings, like the elevations and some sections of the how much the pets should be, how much is the placement of the trees, and you will get the QR code. You can simply scan them and you will get the data of the IDs, how many trees you have, what are their species, what are their sizes. And then you can get also the quantity takeoff Excel sheet format as a CSV data. You can get the detailed data of your parameters, the one you chose here. And here you can see some 3D model visualization of your trees. For example, this user chose like no vegetation box and only like the tree with the bench, and the program itself is going to produce this model that's comparable with environment and comparable with the city rules and comparable with the tree design, with the tree specifications. Without prior knowledge, you simply just choose parameters and the program will choose the best options for you. And here, for example, you can see you can choose like benches and the vegetation box, and it's going to place the trees, the distance between them and the specifications. Like this is the parameter the user chose, and this is the output of the program.
Can you conclude, please?
Yeah, so I argue that the urban planners can use this tool to produce many models for the vegetation and then choose like the best model from them. And also the neighborhood occupants, like citizens, can also use this tool to give opinion to the urban designers that we want this specific, like this type of tree configuration design in our neighborhood. So it's kind of like collaboration between urban designers and the city occupants. And like that's also my conclusion. And we have developed this model in the Ingram Architecture Model Studio program in collaboration